Good afternoon. Guess I'll stand up here. Thanks for joining us. I'm going to talk about a little bit about the history and the context around big data and Hadoop, and sharing my time here with Phil, who's going to talk a little bit more about how this has been realized at British Telecom, BT. So I started a couple of open source projects, Lucene, Hadoop, some others, that have been successful to varying degrees. And in retrospect, people seem to think I'm a visionary, that I have some capacity to see things that they can't. And in fact, I don't have a time machine. I'm no more privileged. I just look at facts and try to guess what's going to happen next. And I've been very lucky in some of those guesses. But nonetheless, I'm asked all the time, tell us what's next. What's going to happen? What's going to happen? And I don't want to disappoint people. And so I came up with a trick to help me do this, which inspired by physics. If you think about velocity, in some sense we can talk about mathematically instantaneous velocity, but in reality, velocity is really something that takes time to happen. Something has to actually move over a time to have a velocity. So it's not just a statement about a moment, it's a statement about a past and a future as well, at least a probable one. Similarly, you've got a rocket, you know where it's pointed, you know where it is, you know how fast it's going. You can predict pretty accurately where it will land. And it may or may not actually land there. It could hit an asteroid, in which case you'd be wrong. But chances are pretty good it's going to go there. Chances are good enough that you will base your plans on where it will land. And so I'm going to try to take some facts that I hope we can all agree on and think about what they say about where we're going, and use them in the style of these physics things. So start with the basics, the thing that I think has really driven us into this big data revolution, which is the improvements that we've seen in hardware. For 50 years, roughly, we've had exponential improvements in the affordability of hardware, in the amount of computation you can do easily. Processors, memory, persistent storage, hard drives, networking, all these things have had this phenomenal growth, unprecedented growth. Can anybody think? I can never think of another technology which has had anything like that kind of growth. Look at transportation, agriculture, any of those kinds of things. We make progress as societies, but not like this. It's phenomenal, and so it shouldn't surprise us that now and then there are phase transitions, if you will, where things become qualitatively different. And I think we're at one of those. But I promised a prediction. So I think that the prediction that comes out of this is just that in the future we will be able to store and process more data than we can today. This trend is not going to stop overnight. So why do we care about data? Data is, as you've been probably hearing all today and all yesterday, is extraordinarily valuable to people, to institutions. As digital technologies are adopted, are spreading through every element of society, through, we have watches that are computers, phones, cars. They're used in agriculture. They're used in just about every industry now has a heavy computational element, and in each of these cases, there's a trickle of data that's generated. In some cases, a torrent of data is generated. And if you capture that, it can give you an incredible picture of what's happened. And if you want to improve, if you want to compete effectively, then you need to first understand what you're doing, what you've done. And data lets you do that. It gives you a high-resolution picture of what you are so that you can then decide what you want to become. I think that's simple, basically. So not only, to make a prediction from this, not only can we afford to store and process more data in the future, but in many ways we can't afford not to store and process more data. Or else we will fall behind. It's become an imperative for most industries. So we need some software to do this. In the last decade or so, a new methodology for software has come to the fore in open source. And I think people learned in past decades to be wary about building their businesses around software that is controlled by another company. If you build your business so it's totally dependent on some other company, then you're exposing yourself to great risk because that company can change the terms, they can increase fees, and it's just not a comfortable situation for companies. And I've certainly seen this in my career, seen technologies whose success, I think, is due more to the fact that they're open source than that they're necessarily technically superior to anything else out there. I certainly put Lucene in that camp. Lucene was and is fine technology, but the reason it was adopted so quickly and widely was that people weren't afraid to adopt it. They weren't worried that someone was going to come and charge them more later. They weren't worried about it being, anyway, all those sorts of constraints that you have when you think about proprietary software were gone. People just said, hey, it works, it does what I want, I'm going to start using it. They could play with it and adopt it. And we've seen this in operating systems with Linux, in mobile with Android, and I think now we're seeing it with Hadoop. That open source is a huge lever. And the prediction I'd make is that a platform technology, a technology that lots of different applications are going to share, is now required to be open source. People will not adopt and standardize anymore. They will refuse to adopt platforms that are not open source. I believe that's where we're headed, and I think that's already the case. So, what open source software is of interest to us? We've obviously at Hadoop Summit, we're interested in Hadoop. When I first started the Hadoop project, we had it running initially on 20 to 40 nodes when we first developed the first versions, and maybe not even running that well. It was fairly limited. It let us do computations which we couldn't do before, so it did give us a qualitative advance. Running something relatively hands-free on 20 machines was not easy before that. But it was also very limited in that we couldn't run it on 1,000 machines. But people started to join in. It was enough to get people's interest. Yahoo invested heavily in getting Hadoop to really scale. And from 2006 to 2008, we moved Hadoop to the point where it did scale to thousands of machines and was fairly reliable. But there were still some sort of gaps in there. It wasn't necessarily highly available. Didn't have any security. Anybody could see anything, could delete anything. One by one, these limitations have been addressed. This last year, we've really seen Yarn come of age. So now we can do a better job sharing resources in a cluster. And I think the prediction is clear that over time, Hadoop's going to become a stronger and stronger component, a base component for data platforms. But even more interesting, I believe, than what's happened in Hadoop over the past few years is what's happened around it. We've seen a large number of projects started that build on top of Hadoop. So Hadoop gave us batch-based MapReduce processing. So very scalable. If you're a Java programmer and your task is appropriate for batch processing, which is what was, as I said, very useful. But a lot of people don't want to program in Java. One of the early responses was the development of Pig. So you didn't have to be a Java programmer to get your computations performed. Pig produced MapReduce jobs on the back end, but people didn't have to write the map and reduce functions by hand. Then Hive from Facebook initially gave SQL as an option to users, so they could use SQL to compose their MapReduce jobs in effect. Again, opened it to a much wider audience, but still batch-based. Then people started doing things that weren't so batch-based. We've seen HBase, modeled after Google's Bigtable, come along, giving us a NoSQL store that's shared on this platform. Impala giving interactive SQL, no longer batch-based. And more recently, Search. Lucene and Solr are now supported as an integrated part of the Hadoop platform. So the trend, again, I think is clear, that more and more kinds of workloads will continue to be supported by this platform. It's becoming more and more general purpose as these tools are added. And it's leading to the degradation of siloed systems. The old style was to build a system for a particular application that was completely independent. And now, since you've got a variety of tools and you can store a variety of data sets, you can build a variety of applications which share the same platform and the same infrastructure. So this, I think, will be an ongoing trend. The more kinds of tools, more kinds of workloads can be brought to this platform. Now we're seeing streaming, in-memory, et cetera, as well as this gradual move of workloads from siloed systems into what we've been calling an enterprise data hub. Some people call this a data lake. I prefer, and it doesn't matter. I think we're talking about the same thing, more or less. I like this because it's a more active thing. A hub is a place where things come together and there's something happening, whereas a lake seems more passive. But it doesn't. We shouldn't spend too much time arguing about it. The interesting thing, I think, is that in some ways these terms are post-Hadoop. It's no longer just about Hadoop. It's about this entire Hadoop ecosystem, and that's kind of a mouthful, and we really need something more. And moreover, I think Hadoop itself is not sacred in this ecosystem. The strength, the long-term strength of the platform is that it can evolve, that it's a loosely coupled confederation of open source projects that no one organization controls. It evolves forward. And so if there's today HDFS is the dominant storage engine, but it needn't always be. The dominant computing framework used to be MapReduce. That's changing. People are doing a lot outside of MapReduce today with other computing frameworks built on top of this system. So it's an exciting time, and I think because of this architecture of an open source platform with decentralized control over it, people can adopt it as a whole more comfortably without having to worry that they're going to get locked into any one component. Anyway, that's all I really wanted to add. It's a quick overview of how I think we got where we are. Now I'm going to let Phil come up and tell BT's story in this regard.
Okay.
And then we're going to have some time for questions at the end. Thank you.
Doug. Okay. So that's me. I'll tell you a little bit about myself. So I've been with BT for longer than I care to remember, 28 odd years. And I thought for about 15 of those I was doing big data. It wasn't called big data. I built huge network management systems that process hundreds of thousands of events every minute. We shifted data around. So the non-functional aspects of data and processing data is something we've been doing a long time. It's just now we see a new technology that's coming along that we're going to help use to expand the enterprise. So I won't talk a lot about how we're structured. I'll just talk a bit about the culture of BT. So BT is kind of an old school technology company. And we admire the new wave of internet real estate enterprises like Yahoo and Google. But we've been doing innovation for a long time. Arguably, we were the world's first telco over 100 years ago. We built, as part of the Bletchley Park operation, we built the world's first programmable computer, Colossus. We did the world's first digital telephone exchange. And if you bring it right up to the present, last year we bought the rights for Premiership TV football in the UK. We built a TV studio. We run 2 24-hour-a-day TV channels. And we figured out how to stream live multicast HD with millions of people watching live sport on a Saturday afternoon across our network. So whilst I can't predict the future like Doug, I do know the past. And there's a pretty good trend line. To me, that looks like that rocket, and there's just more transformation coming. So we might as well get on with it. So there's a little concept that I use, and this is, so the kind of, there should be a little thing that says source Gartner or IDC. So this says source my head, okay? So, and it's just the way I think about this. So basically what we have is, a long time ago, but even before I joined BT, we were doing mainframes and we were doing batch processing. Sound familiar? But it was really useful and it really helped us a lot. And we still have mainframes. In fact, we actually spent some money on mainframes a couple of years ago to keep them going a bit longer. So the mainframes are there, but they're very, very small part. And they're in a gradual but steady decline. And the data is stored in files in something called IDMS, which is a file-orientated database. In the kind of mid-80s and 90s, the relational database appeared. Some of you may have read Ted Codd's story, a paper on the introduction of the relational database technology. And suddenly, massive amounts of our data are in relational databases. And so here we are today, 2014 at Hadoop Summit, and some proportion of the world's data is in relational databases, and some of it is in Hadoop. And I can't give you the numbers on these curves, but you can pick that gradually relational is going to go in a gradual, steady decline, just as the way the mainframes have. The batch processing that started out in Hadoop will get more and more real time. This is conjecture, and more. And as the world's data expands, then Hadoop will expand to consume it. So this is this concept of peak oil. So the question is for any IT and any enterprise, at what point in time do you invest in this new technology? Is it when it's mature enough? And our view is that is now, and that's what I'm going to talk about, our journey. So why Hadoop? So we have lots of data, and one of the major costs in our IT estate is filers. Anybody who's got a large enterprise, particularly with relational databases, will spend millions of dollars on filers. And gee, wouldn't it be good? And not all the data we have on the filers is really valuable, but we would be good if we had a cheaper place we could put it. So that's one kind of simple thing. The schema on read allows us to get to a much more dynamic BI. So ETL is a very manual intensive process. You have data architects, data designers You go out and figure out the schema and put the schema in the database before you load one row of data. I'm a data architect, so I don't really like things. I'm not comfortable with processing data without a schema. But I compromise and say, well, actually, I know what my conceptual schema is, because I know broadly what the sort of data it is, and that's good enough to me to say, let's bring it into the cluster. We'll worry about whether that's a varchar 200 or an int when we got it in and we start to read the data. So cost. So we're an enterprise. We're here to make money for shareholders. We're here to do good things for society. But at the end of the day, we have to put the business cases before the finance department. So there is no doubt about it that the lowest cost per terabyte of storage in our organisation is Hadoop. And of course, it's open source. We have an open source conference. So that's another important factor. And the other big problem we have in the enterprise is data integration. So we have an n-by-n matrix of systems, and no matter how many interfaces you build, somebody always seems to find a way of going, well, actually, I want that data to go from that system to that system. And so you just end up with this, complexity is extremely difficult. It makes it hard to run the estate. It makes the system estate unreliable. When things break, it's hard to diagnose. So you'll see the vision we have is one of simplifying and using the Hadoop as the data hub. And if you're as old as we are, you have an IT estate, we have machines that are hopelessly end of service life. They're not particularly important to us, but they're there. We focus on the business critical systems, keeping them upgraded and patched and so forth. But there is a lot of the estate that we would really like to retire, but we keep it around. It doesn't have data coming into it. So we have an end of service life. It's a continual issue in the enterprise. And Hadoop provides us a platform where we can actually re-platform applications onto Hadoop and just shut down the old infrastructure. And of course, linear scalability. So that was the thing that really kicked me off. Having spent all my time arguing with network guys, they want the data every 1 minute and they want all of the metrics, and I could only give it to them. So, well, you can have those 6 metrics and we can only really put them in 15-minute buckets because that's all we got. And suddenly now with Hadoop, I can say, well, look, if you've got the money, we can just scale out the tin. And it's as simple as that. So, Christopher, how valuable is this to you? Okay, so I'm an architect, so I have to have a funny slide like this with lots of blobs and boxes on. So this is a massive abstraction of our estate. So please don't think, these lozenges are our main business units. So please don't think that BT Global Services has 7 databases, okay? It has more like 700. Across our estate, we have something like 1,400 significant Oracle relation databases. We're a big Oracle shop. And in every business unit, we have a very significant data warehouses. Some of these are on Exadata boxes, multi-terabyte databases, and a large community of hundreds of users hanging off each one of those warehouses. So, typically we have a CRM at the top. We take in an order or a fault. It works its way through the stack and does something down in the network. And we have a whole bunch of network management systems in there watching the network, watching the TV streaming over the network. So the vision that we have for Hadoop, and we have a lot of governance around that, and data security, and we have all of that good stuff, and we have a big security department. Security is very important to us. We make a lot of, we sell it as a managed service, and we have a lot of personal data, so it's really, really important to us. So what we're doing with Hadoop is we're bringing it in as this fundamental foundational layer, and this is not all built. This is obviously a vision. Some of it's built, and I'll show you what we have built. But basically, every Oracle database that needs to, and this really means an application, will basically have a connector, and it could be file, it could be scoop, they're all to be designed and delivered, lands its data onto the HDFS. We're going to have a Hive layer over the top, and we're going to use Sentry for data partitioning at the table level. A lot of these systems are old and economically constrained, so we can't invest in them, and they can only hold 30 days worth of data. Now, actually, the business would like a year's worth or 3 years' worth of data, and they would like to record special events. So when we get a really, really windy day, we have a network with poles and wires. It's important to us to understand the effect of weather on the network, and how many jobs that causes, and all that kind of stuff. So we'd like to build up much, much deeper history. We'd like to keep fine-grained history, not aggregated history. So just in each one of these applications, so these are color coordinates, so that orange database has its history down on HDFS. And then we'll start to develop applications on the cluster. So ETL-type pipelines or pig scripts, where we might start to do analytics, or we might just use it as an MDM. I'm also responsible for master data management in BT. I would like this to become a vehicle for unifying our MDM. And of course, metadata. So I'm a data architect, so data dictionaries, metadata is really important to me. And actually, one of my big challenges is how do I get all of these Oracle data dictionaries into the Hive metastore and then make them available to the business people so they can find out what data we have in the cluster. And we don't just end up with a huge garage of data. And then we have a lot of data in the cloud. So the business has been really keen on outsourcing things, so SaaS-type applications, and that data is out there. We want to integrate it with all the other data. So we're going to use Hadoop as being the way of bringing that, repatriating that data. And of course, all of the new external data feeds, all integrated with our corporate Active Directory. So this is what we've built. We are launching a multi-tenant service. So we haven't gone a project-by-project basis. This is a centralized architecture. We're delivering it through the data center teams as a service that projects consume. Multi-tenant Hadoop cluster. We have a regulatory requirement to split, and that's why there are two clusters. One of the business units called OpenReach has got a Chinese wall around it through the government to require them to have separate system stack. So that's why it's two clusters. We have actually been running a research cluster, so if you do have a time machine, you can pop back a couple of years and do some research on Hadoop. I really recommend that as a technique. So we launched it in March this year, so only a few weeks ago, integrated with that one. We've got two 1.2 petabyte clusters, so there's 24 nodes in each. Dual hex core, 12 by 4 terabyte disk. So there's a decent sort of starting size, and we have enough space. We're planning it will probably double every 6 months. So there'll be a few hundred nodes within a few years. Okay, so these are our use cases. We have a governance board. We're an old company. We do architecture and governance. We have a quite established governance, and we approve all the projects that come on. So the 3 data warehouses are already starting to consume the service. We have 2 old applications that we're replatforming. The security guys want to put a bunch of security data in there. So that's what's approved and has hard business cases. What's in scoping at the moment, some network monitoring. Next week we've got a hackathon where we've got to configure up Scoop and see if we can get a bunch of our home hub broadband data in. Couple of apps that want to trim down their Oracle databases, but they don't want to delete the data. So we said, well, you trim down the data and put it into Hive. And about a dozen others at sort of a conceptual stage. So that's why we've got a multi-tenant, because if each one of those projects built a cluster, I haven't solved my N-by-N data integration problem. I've just made it worse. Okay, so I was a programmer. I haven't cut much production code in a few years. My coding these days is there's a few lines of Python on a Raspberry Pi with my son. So I can impart some grey hair wisdom as my contribution to the community. So develop your architectural vision. So that one single diagram has been up on rather a lot of PowerPoint slides and rather a lot of meetings, and it's generated lots of discussion and helped senior management understand what is this strange big data technology. Is it the same as what we've got? Is it something new? So it really helps to have that clear view of where you want to get to. So one of the things I'm quite passionate about is single cluster for the enterprise. A lot of people, and particularly businesses, are not comfortable with sharing their infrastructure. They really like to say, well, we'd really like to have our own cluster over here, and we have this budget, and we'll just buy that. And on a number of occasions, I said, no, actually, it's not going to help. What we're trying to do is integrate the data. So please, just, if you can find a legitimate reason in 6 months, then we'll look at doing a cluster. But can you at least start by playing nicely with the rest of the guys? So get the data center guys to build it. Don't get the application teams to build it. I had to spend about 3 or 4 months working with my colleague Tim, who's our data center architect, and he just built something called a cloud. It was enterprise cloud, and he was really proud of it. And he just told the business that that's it, we built the cloud and we're done. And so he was saying, well, I could just virtualize Hadoop and that's it, we're done with the Hadoop thing. And I said, well, Tim, that's not going to cut it. When the loads start getting bigger, it's going to blow up your virtualized infrastructure. So eventually they recognized that separate tin infrastructure is the way to go. And so now we have a view that between Hadoop and our enterprise cloud, that's probably all of the IT infrastructure we need. So don't be letting them fly production elephants in the cloud. It's a stupid thing to do. Okay, so focus on delivering benefits. So I have talked quite a lot about architecture and cluster, but at the end of the day, we have the finance guys, and they are only interested in benefits. So that's why we have that governance board. Every project that comes onto the cluster has to tell us exactly where it's saving money, what business process it's going to change, which bit of customer experience it's focusing on, how many they're going to save a number of engineer call-outs. These all have dollar values that the finance guys relate to. And of course, get security sign-off as soon as possible. I have a sort of another group that does data security and enterprise security, and I have to meet with them on a regular basis and tell them what we're doing. We have clear policies about the sorts of data that we can come onto the cluster. So at this stage, we're not bringing on personal data. We have more than enough network data and other stuff to deal with. We'll worry about encryption and that kind of stuff as we get down the track and we mature a bit. And have fun, So 4 or 5 years ago, data architecture was dull and we couldn't get people to participate. And suddenly, everybody is knocking on my door, sending me emails saying, how can I get my project onto Hadoop? And what are we going to do to add more value? So it's cool again. Okay, Doug, I think we got some, that's me, I think we've got some time for some Q&A.
If you're going to ask a question, I think they'd like you to come up to the mic.
Sorry, but could you use the mic? You want to just pass this one round? Yep, okay. I will do a compare roll. There you go. Thanks,
Phil, about 3 slides ago, you asked a question, I think, how are you going to import the Oracle data dictionaries into the meta store and not end up with a garage at that point? How would you answer your own question? Because it's something I'm interested in as well.
So I was just chatting with Alan Gates yesterday, and we're going to have a word with Yahoo. We might do a project around that. We figured out that in Hive you can do extended properties on the databases. So when we create each service instance gets its own Hive database secured by Sentry, so nobody else can get at that data. We'll be tagging that with extra DB properties, so things like application ID, application owner, governance status, that kind of stuff. And we'll then harvest that out of the Hive metastore and publish it via SharePoint so we can keep track of what's going on. So that's our sort of version 0 stuff. The vision that we'd like is, and what's in my head is something like a data media player where you can go in and you can browse and say, I'm interested in faults, I'm interested in rock and roll faults from 1950, I'm interested in this product, and we'll then go, oh, okay, so there are 4 data sets on the system that we have. This is the size. This is who you need to speak to get access to them. And also, better still, it's Hadoop, so let's do a recommendation engine. So the last 6 projects that looked at that data set also looked at these other 2 data sets. So you might want to join that together to enrich it. So there's kind of baby steps and an aspiration. Yeah, do you want to? Yeah, I think maybe for the video they...
I've got some grey hair, so I came from the mainframe background. In terms of grown-up computing, I'm still missing the concept of backup in this story. And I accept you've got failover and duplicate data, but I'm missing disaster recovery, all the things that mainframes were good at. It seems to me that backup technology or the approach of backing up your data hasn't kept up with the ability to process data.
So we are single site at the moment, and that's what's known as HAS Release 0.9. There's a 1.0 release which is adding some additional features, so things like CDH5. The major release 2 will be the second site, and we're discussing the enterprise cloud is in 2 sites, so we're going to put the second Hadoop cluster co-load with one of those, and then we'll put N by 10 gig links between the 2, and I'm speaking with the network guys, fortunately we're a networking company, about where's the best place to, and have they got fiber capacity to provide me a 10 gig link between those locations. So we will basically replicate the data. We think the second cluster will be a smaller cluster that runs production SLA workloads with hard SLAs on. And when that fails, it will fail back to the big cluster, which is the one that we've actually built now. So we have a way to do that. But there is a conceptual thing where, at least at the application level, you have to conceptually say, I accept the fact that I may lose some of this data. And if it's critical data, it'll still stay in the Oracle layer, and it'll be on the filers, and we'll have to live with that level of duplication. But yeah, it's not perfect. It's a bit like that thing about, not having all of the schema when you land the data. It's kind of a compromise.
There are a variety of disaster recovery tools in the Hadoop space, and more coming along every day. I mean, this is the standard practice is to mirror, and depending on which tools you're using, and the demands of your application, how up to date the mirrors need to be can vary. So I think there's built into HBase, you can have it updated in real time. And anyway, it's an active area, and I think you'll see substantial improvements over the course of this year in disaster recovery tools, and more and more of that is getting built into the base platform.
Thank you.
You're not alone, and people are working on it, and some of the work is even done. It's the short answer. I don't want to go into more detail. But.
Thank you. Hadoop in the cloud. I understood it's not such a good idea. Can you tell us more about that?
Okay, so we're a cloud provider. So at the moment, all of this is about internal IT. So that's kind of where we're at. I guess there are enough different factors involved without having to worry about getting the data in and out of the cloud. And just from an enterprise point of view, we want to bring the data back inside the enterprise. A lot of the applications and data have already leaked out into the SaaS applications. We want to bring that back. So, but I can't really say I haven't used Elastic EMR. We didn't really seriously look at it because of the scale we were looking at. So, it was kind of part of our. We consider this part of our core infrastructure. So. That bit will be on-prem. We might burst out into the cloud. We might do proof of concepts on EMR and stuff like that. But I don't think it'll be a mainstream part of our architecture.
Thank you.
Do you have separate stages for development, testing, production, or do you do everything in one big cluster?
Some of the application teams have got their own local capabilities, so we accept the fact that they may have a local cluster, or a lot of people are just using the sandbox standalone. If you're writing pig scripts, so you do it on your laptop with the sandbox. We have a reference cluster for those two production clusters. I think it's true to say that that's probably an area where we're still maturing. We'd like to get better code control and version management. I don't know, Doug, whether there's anything else in that from a sort of a versioning and production migration. I'm always fascinated by how Yahoo and those guys handle, because you do that sort of stuff.
It's pretty common to have a development cluster. If for no other reason, you can test upgrades to the platform and test that your things work well with the upgrade before you actually upgrade it. And so that's a fundamental reason you need at least some test environment. I think there's a tendency to try to build multi-tiered ones. I think that's oftentimes overkill. But having a development and a production separated is pretty common.
So it's probably worth saying that we do. So within the HAS environment, what do you get when we create a security group, a principal in Active Directory, then we create the resources on the cluster, so the Hive database, the home directories, and then we bind the two together. And we tag the cluster, the service instances with a type. So this is a dev, this is a test, this is another, which is the admins messing about or training or production. So we haven't got all the dashboards worked out, but the idea is that we can look at production loads versus dev loads. And we're going to use Sentry as being, okay, so we want to have an offshore dev team that can't see all the data, they can only see a subset. So using that, we can then apply a view, which has got a query as well as a restricted set of columns, and they can only get at that subset of the data. So we have a framework to do dev test, and we have the operations guys who are doing change control on the platform. So we have a sort of a basic framework. I don't think it's going to be perhaps I'll come back next year and tell you all the problems we had, and what we solved.
Going to say for a better answer, our next speaker.
There you go.
Well, I'm sure touch on these things. I encourage you all to stay around and listen to Alan, because he's been operating and building Hadoop clusters for longer than anybody, probably.
Okay.
Any last quick questions? We're just about out of time.
Okay.
Thank you very much. Oh, wait, we got one. We got the mic.
So we spend more money with Oracle on software packages, PeopleSoft, eBusiness Suite, the support that we play on the relational database. Well, he would probably say go speak to Larry, you know, and it's above my pay grade, and that's just my personal opinion. And I'm the data architect for BT, so. And I also don't think that, you know, Hadoop is not the end of it all. There are lots of interesting new technologies, the graph databases. We're really interested in running that in Yarn. Some of the in-memory stuff that's coming along. You know, we really ought to be doing more columnar stuff in our warehouses. There's lots of other technologies that we have to grasp, but this is a really, really important one to get in at the foundation level. So.
Thank you.
Okay, thanks.